Right, good morning everybody. My name is Ian Heathcock from Inoapps. As a leading technology and applications partner, Inoapps jointly hosts a variety of these webinars with our colleagues from Oracle. Today's session will explore how the latest generation of coherence tools from Oracle can help organizations to address the challenges of data access bottlenecks that slow applications or prevent them from scaling. Your presenter today is David Felsey from Oracle. Just before I hand over to David, a couple of points of housekeeping, if I may. Today's session will be recorded and available for viewing via Inoapps' website, a link to which will be sent out over the next 5 to 7 days. Please feel free to share this link with any of your colleagues who you deem might find this of interest. Telephone lines for this conference have been muted. Should any questions be arising during the session, please use the chat bar on your panel, and we will then ask those questions on your behalf at the end of the session. Should we be unable to answer any or we've run out of time, we will get an email of those answers back to you as soon as we can. During the session, we will also be conducting a short poll for which we would request your participation. A multiple choice question will be displayed. Simply select your response and submit and press the submit button. So, without further ado, I will hand over to your presenter for today, David Felsey. Thank you, David.
Hi everybody, thanks Ian. Today we're going to talk about coherence, Oracle Coherence. Going to cover off what it is, how it works, and then also talk about the benefits of it, how customers are actually using it to improve application performance and scalability, reduce legacy system costs, and integrate web applications. So it's all about providing faster access to your data and making that access scale up. So what is coherence? Coherence is an in-memory data cache. So effectively it's a way of reusing data that your application needs, rather than going back to the original source again. It also provides very fast access to data, typically in milliseconds. So the data is actually held in memory, it's not held on disk, and so it's very fast to actually retrieve that information. And it's ideally suited for both real-time and transient data. Now these sort of criteria of what coherence is, it isn't sort of extremely tight in terms of it can only do these things. It's really this is the predominant use cases where you'd actually utilize coherence. So by real-time data, I mean that if your data changes frequently and you want information about how it's changing, when it changes, then that's a really good use case for using coherence. Transient data is also ideal for storing coherence, so information which you don't necessarily need to persist to a database, things like HTTP session information. What isn't coherence? Well, coherence isn't, although it can store terabytes worth of data in coherence, that isn't the ideal use case. So if you need to hold multiple terabytes of data, or you need a data warehouse, then products like Oracle Exadata is much better suited to that type of use case. It also isn't a SQL cache, so you access coherence or the data held in coherence through programmatic APIs. There isn't a SQL API, and if you need fast access to SQL data, then products like Oracle x10, which is a database cache, are ideally suited for that use case. And generally coherence isn't embedded in products. So for instance, we do have customers who embed coherence. TIBCO, for instance, embed coherence in one of their products, and other vendors do. But typically that's not a common use case. If you want to embed a caching technology in a product, like in a router or something like that, then Berkeley DB is ideally suited for that. And finally, caching web content. So if you want to cache web pages to serve them up from memory as opposed to going back to disk and rereading from disk, then we have another product which is ideally suited to that, which is called Web Cache, Oracle Web Cache, and that's very much focused on serving up images, JavaScript libraries, web content. But coherence is used in all of these use cases to some extent, but it's not ideally suited for this. So the top three that I've outlined, so reusing data that you fetch from a data source, providing very fast access to information, and storing real-time or transient information. So now I'm just going to conduct a very quick poll, and really what the idea of this is to find out where people's interests lie and you know what you're doing at the moment in terms of caching, so that the rest of the presentation can be geared towards what the audience is looking to get out of this session. So over to you, Ian.
Okay, thank you, David. So, all being well, you ought to be able to see your screen there. You've got the 4 choices as David's alluded to. If you could select the one that's most appropriate to you, and then simply press the submit button. All right, I'll give it a couple more seconds just for the last 1 or 2 to enter their choices, and then we'll close the poll and share the results accordingly. Right, let's close the poll, and there we go, David, there's your results.
Oh, I can't see those at the moment. Do I need to, can you read them out, because I can't see them on my...
Right, okay. The majority, 75%, are considering using caching technology, with 25% are currently using open source caching technology.
Okay.
So at the moment we've got no takers for the Oracle Coherence or caching products from other vendors.
Okay, thanks for that, Ian. Thanks for your participation.
Okay.
That'll give me an idea of the audience I'm talking to, and also I can compare and contrast how Coherence works with some of the more popular open source caching technologies, so you can see where Coherence would play against those. So what's the Coherence approach? Well, the key thing for Coherence is making communication efficient, so we don't rely on a broadcast mechanism. Coherence is based upon Java, and effectively you start up a number of Java applications, and those Java applications talk to each other to form a cluster. So that's a pool of Java programs which can all communicate with each other, but they use peer-to-peer communication. They don't use multicast or broadcast messages, and that means that you can scale to quite large numbers of Java programs to form this virtual pool of cache data. There's no voting, so for instance you don't, if a Java program which forms this cluster fails, you don't then need to have a vote amongst the existing members for who's going to be in charge next. In fact, there actually is no person in charge in Coherence. There's no single point of failure, and there's no single point of bottleneck. So requests to get data out of a cache or put data into a cache don't have to go through any particular member. There's no lookup service, for instance, and there's no member of the cluster which is more important than the others, in the sense that it needs to be up and running all the time. And Coherence is very fussy about who's a member of the cluster. So when you start up these Java programs, these Coherence cache nodes as we call them, they all talk to each other to form a cluster to hold data in. And if any member of that cluster isn't functioning correctly, so isn't returning messages as quickly as it should be, or is missing some timeouts and things like this, then it will be ejected from the cluster. So there's about 10 different health checks that go on amongst all these Java programs to ensure that the cluster is functioning and working correctly. The underlying protocols that are used to actually communicate between the Java programs is actually UDP. So UDP is the underlying protocol, but on top of that we layer a proprietary protocol called TCMP. TCMP actually stands for Tangasol Cluster Management Protocol. Coherence was originally developed by a company called Tangasol that Oracle acquired about 2 years ago. And this proprietary protocol really gives UDP its reliability, because UDP is great, go through routers, firewalls, etc., but it's not a reliable protocol. So by